Good morning, sir. I'm Neo Yingshan. Today, I'm going to present about text mining and sentiment analysis on customer review. Sentiment analysis is a technique used to determine the emotional tone or attitude expressed in text, categorizing it as positive, negative, or neutral. Lexicon-based method and machine learning method will be used for this sentiment analysis. This analysis works with a dataset of over 20,000 TripAdvisor hotel reviews, each paired with a numerical rating containing two key columns, review and rating. Main goal is to apply sentiment analysis to extract meaningful insights from customer feedback and turns raw reviews into actionable insights for the hospitality industry. By understanding sentiment trends, hotels can spot areas for improvement early and make data-driven decisions that boost overall guest satisfaction. Let's take a look at the methodology and pre-processing of the dataset. The analysis began by taking a 40% random sample of the dataset using my student ID to ensure uniqueness. The analysis used two methods. First, the lexicon-based method with the text block library. This assigns each review a polarity score from -1 to +1 and pair it with the numerical rating from 1 to 5. Ratings and polarity scores were then converted into sentiment categories which are positive, neutral, or negative, and stored into two columns, true sentiment from ratings and predicted sentiment from polarity, which allows for direct comparison. Second, we apply a machine learning method using multinomial naive Bayes to train the dataset. Reviews were pre-processed with NLTK to tokenize, lowercase, clean, stop words removed, and lemmatized to reduce their base form. Then, we used TF-IDF vectorizations to turn text into numerical features. The model was trained to classify sentiment, capturing context effectively, and performing well on large review datasets. The lexicon-based sentiment analysis achieved an overall accuracy of 78.61%, means it correctly classified nearly 4 out of 5 reviews. From over 8,000 samples reviews, the model showed a strong bias towards positive sentiment. Most reviews were labeled positive, while only 545 were negative and just 9 were neutral. This reflects both the positive tone of the review and the model's limitations in detecting neutral feedback. In terms of classifications report, precision was high for negative, 0.86, and positive, 0.78 sentiments, but actually low for neutral at 0.22. However, the F1 score is highest for positive, which is 0.88, but 0 for neutral, reflecting poor neutral classification. The confusion matrix shows that the model frequently misclassifies neutral and negative review as positive. It incorrectly categorized 835 neutral and 832 negative as positive. The model also fails to detect neutral sentiment. Thus, the false positive rate is high. Next, the machine learning model achieved a solid overall accuracy of 78%. It classified about 7,623 reviews as positive and only 573 as negative, showing a strong tendency toward positive classifications. It is more reliable than the lexicon-based model in capturing critical negative feedback. The model performed well on positive reviews, with a precision of 0.77 and perfect recall of 1.0, meaning it correctly identified all positive cases. For negative reviews, precisions were high at 0.93, but recall was low at 0.35, indicating it missed some negative instance. Neutral sentiment detection remains a challenge, with 0 precisions and recall. The confusion matrix correctly classifies 6,000 positive reviews, but only 538 negative reviews correctly recognized, often mislabeling them as positive. From a hospitality perspective, the lexicon-based methods, while suitable for high-level sentiment screening, this model is not reliable for actionable decision-making because the false positive risk is high, and negative feedback often misclassified as positive. This could mislead hospitality businesses into overlooking service issues. Moreover, the machine learning model's strong positive detection helps recognize satisfied customers quickly, while identifying most negative feedback allows early interventions. However, the model will miss neutral sentiment. Enhancing neutral detection will further support targeted marketing and customer satisfaction efforts. In conclusion, both the lexicon and machine learning models achieve similar accuracy, 78.61% and 78% respectively, but they both struggle to accurately classify neutral sentiment and show a bias toward positive predictions. However, the machine learning model performs better overall, misclassify fewer negative reviews 763 than lexicon method 832. For the hospitality industry, this means businesses can quickly identify satisfied customers and reinforce successful services, supporting targeted marketing and fostering customer loyalty. To address the limitation, future improvements should focus on oversampling minority classes and using balanced, diverse training data. Oversampling minority classes means increasing neutral and negative samples in the training data to balance the dataset. This will help the model better recognize all sentiment types and enable hotels to proactively enhance their services. That's all from me. Thank you.